Okay, this is the first video for activity 15 and the third video for the video series on activity 13 and activity 15, which is the test that you or the quiz you'll be taking altogether with these two activities. So activity 15, we start quadrilaterals, and with that we start lesson 15.1, which is kites and triangle mid-segments. Our learning targets today are to develop properties of kites, and then we're not actually going to prove the triangle midsegment theorem. We're just going to introduce it. Okay, so kites and triangle midsegments. So first, before we even get to kites and triangle midsegments, we want to just talk about what a quadrilateral actually is. So a quadrilateral is a four-sided figure. Alright, so any shape with four sides, okay? Alright, there are two different types of quadrilaterals, what we call concave and convex quadrilaterals. A concave quadrilateral contains an interior angle that is greater than 180 degrees, and that's why we have this little caving in quadrilateral. We really won't be dealing with these much this year, but what we will be dealing with is what we call convex quadrilaterals, and these kind of quadrilaterals have all interior angles which are less than 180. So you'll see them looking something like this, okay? We have a bunch of different types of quadrilaterals, and that's what we'll go over in this activity. So in this lesson, we will be focusing on convex quadrilaterals. In each convex quadrilateral, there are two pairs of opposite angles, two pairs of opposite sides, four pairs of consecutive angles, four pairs of consecutive sides. Also, each convex quadrilateral contains two diagonals. So when I say consecutive angles, I mean they're right next to each other. Kind of, if you look at our convex quadrilateral, so say angles 1 and 2 right here would be what we call consecutive angles. Angles 1 and 3 up here would be what we call opposite angles because they're opposite the shape from each other. And then very similarly for consecutive sides, those are just two sides that are touching. So those two, how about those two, and then of course those two. So that's four pairs right there. And then opposite sides are just the sides that do not touch each other, okay? So like the top and the bottom, and then the left and the right sides right there will be what we call opposite sides. And you see there are two pairs of those. Okay, so diagonals is a line. A diagonal is a line you just draw from one opposite angle to the other. Okay, those are what we call our diagonals. So let's take a look at quadrilateral GEON that we have to the right here. What we're going to do is complete the table below with what it's asking for. So in the first line, the first row, it asks us to list all pairs of opposite sides. Okay, so we have two pairs of opposite sides, as it said in the the paragraph above. Okay, so one pair would be, let's say, how about GM and EO? That's one pair. And then our other pair would be the top and bottom right here, which would be GE and MO. Okay? Now consecutive sides we said are the sides that are just touching. So we have four pairs of these. What I like to do is I like to start with one side. Say I'll start with GM. Okay? And then I just go around, say let's go counterclockwise. So GM and MO would be one pair of consecutive sides. Alright, if you notice that consecutive sides are always going to have a one letter in common. Alright, another one, we'll go MO and OE. I'll go back and write my little segment symbol at the top. Now OE and GE. And then our last pair will be GE and GM. Okay, so those are four pairs of consecutive sides. Now let's move on to angles. Opposite angles will have angle G and angle O. and then our other pair would be angle E and angle M. All right, for consecutive angles, again, we have 4 of these. So again, I'm just going to start and go counterclockwise around my quadrilateral. How about we start with angle G, angle M, then angle M, angle O, angle E, and then angle E, angle G. And those are my 4 pairs of consecutive angles. So our last row says draw the diagonals and list them. So draw a diagonal between E and M, draw a diagonal between G and O. Okay, the 2 diagonals, how we would write them as segments, of course, because they are segments that we've drawn with endpoints, which are these opposite vertices right here. So one diagonal would be GO, and then the other one would be ME, go me. Okay, so that's quadrilaterals, a little introduction and kind of going over the terminology you'll be seeing as we do this. So let's talk about a kite. So a kite is something you fly in the air, of course, right? And they're generally going to have a shape like this, like a classic shape of a kite. Looks like that and has a little string, maybe some bows on it. Okay, so this shape at the top that's actually being flown is actually a geometric term called a kite. Okay, so kites have different properties and special properties. So let's talk about what those properties are and what a kite actually is. So a kite is a quadrilateral, meaning it has 4 sides, with exactly 2 pairs of consecutive sides congruent. Okay, so it means 2 sides that are touching will be congruent. We have 2 pairs of those. And then no opposite sides congruent. Okay, that's important too. No opposite sides are congruent. So if we look at our kite, K-I-T-E, to the right here, I can just kind of tell that these 2 that are touching are going to be equal right here, since I know there are 2 pairs of congruent consecutive. And then those are the other 2. That's the other pair. Okay, notice that none of the opposite sides are congruent. Okay, so right here it says given quad kite with Ki congruent to Ke and It congruent to Et, which is what we've written on here. We've already marked our congruent sides on the quadrilateral. All right, so it says of the 2 diagonals, draw the one that will divide the kite into 2 congruent triangles and list it below. Okay, we're not going to explain how we know that the triangles of form are congruent. So I have 2 diagonals. I could draw this one, or I can draw this one. All right, the first one we drew, those triangles do not look congruent. So congruent triangles basically mean that they're the same shape and the same size. Those are not the same shape and same size. But when I draw this one, it is this. They very much do look like 2 equal triangles, right? One just kind of flipped over the other. So the diagonal that we draw will be, that was KT. Alright. Okay, now it wants us to draw the other diagonals. The other diagonal. I draw that. What do you think we can say about the 2 diagonals? I'm going to take a look at this. They look like they are perpendicular, and actually that is correct. The 2 diagonals are perpendicular, so we'll say they are perpendicular. We'll write this little shorthand right there. Okay. So let's go over our 6 properties of kites. You do need to know these. These are important. So put some stars on your notes if you need to help you remember to memorize these. Okay, we've already gone over the first 3 properties in what we've done above right here. Okay, so let's just talk about them again. Exactly 2 pairs of consecutive sides are congruent. That's what we did when we marked our sides with the hash marks. Number 2, one diagonal divides a kite into 2 congruent. Instead of angles, this will be triangles. Okay, and that's KT does that for us. So we can even write KT right here if we want, just to give an example. And then the diagonals of a kite are perpendicular. Remember, if 2 things are perpendicular, they intersect to form right angles. So that's what we did in our last little bullet right here. All right, number 4 is going to say, is going to be that one diagonal divides a kite into two isosceles triangles. So we had two congruent triangles the other time, and this time we're just going to say we're two isosceles triangles. So let's go back and look at our thing. So how about we take a look at this diagonal? If I look at that one, okay, I see obviously there are two isosceles triangles. Isosceles triangles are triangles in which have two sides that are equal or congruent. This one on the right has two sides, which are these ones with that are marks on them, and then the same for the left triangle. So we'll say that the diagonal that does this for us is diagonal IE. Remember that's a segment with a line over the top, okay? All right, 5. One pair of opposite angles are congruent. All right, so let's look at what we got here. So I'm going to either guess it's K and T or I and E. So if we remember correctly, when we drew our diagonal, the other diagonal, we were left with two congruent triangles, right? Okay, and we said they were kind of just a mirror image of that line. So that means that the one pair of opposite congruent angles right here are going to be angle I and angle E. So angle I that looks terrible, sorry. Angle I is congruent to angle E. Alright, our last property is one diagonal bisects a pair of opposite angles. Okay, we remember bisects means to split directly down the middle into two equal parts, okay? So let's look at what diagonal is going to do this. Alright, so I draw KT right here, and it looks like it's splitting both of those. It's going down those angle K and angle T directly down the middle. If I was to draw this one, it's not going to go directly down the middle. I see this angle is kind of a little bit bigger than that one, and that tells me that it's not actually bisecting those angles. But what we do is we have that these angles are congruent and these angles are congruent, those two right there, because it's being KT is bisecting those angles. So we'll say right here, the diagonal that's doing this bisecting is KT. Okay, now let's answer some problems. Number 1, in quad KITE above, does KT bisect IE? Alright, question, does KT bisect IE? So remember, bisecting means split directly down the middle into two equal parts. Does KT bisect IE? Yes, it does. These two look about the same. So what that tells me is that these two are congruent. Alright, so that's a big yes. Is this question the same the other way around? Does IE bisect KT? I can obviously tell that this K from K to where they intersect is a little bit smaller than the other little segment on the right. So we're going to say a big no for that. Okay, we don't need to even explain. All right, number 2, figure ABCD is a kite. Complete the statements below. So BD is perpendicular to what segment? So I know the diagonals of a kite are perpendicular right here. So I can say BD is perpendicular to AC. All right. Triangle ABC is congruent. So ABC is congruent to ADC. All right, so triangle ADC. All right, angle ABC, which is this angle, is congruent to angle ADC. All right, AB is congruent to AD. And then finally, angle BAC. So BAC is this angle. It's congruent to angle, actually, DAC. And that is that one right there. So this kind of just uses our properties of kites to fill out some congruent statements we have right here. We're going to skip number 3 and move on. Triangle midsegments, okay? So we're going back doing some stuff with triangles. So a triangle midsegment is a segment whose endpoints are the midpoints of two sides of a triangle, okay? So if we look over here, we can scratch out these coordinates because we're not going to need them actually. I just want to know this is triangle A, B, and C. Okay, so MN is going to be a midsegment. Okay, so since it's a mixed midsegment, we know that we draw midsegments from the midpoints of two sides. So we could say M and N are midpoints. So M is a midpoint of AB. N is the midpoint of BC. Alright, so that's important to know because you'll be using that to solve some questions. So now that we've kind of gone over what a midsegment is, let's go over our triangle midsegment theorem. First part says that the midsegment of a triangle is parallel to the third side. What I mean by the third side is the side that we haven't done anything with. We've done something with AB and we've done something with BC. So we can say what we're saying now is that my midsegment, which is MN, the theorem tells us that that is parallel to that third side, which is going to be AC. And you can kind of see that. They're parallel. They're never going to intersect. Okay. Number 2 says the length of the midsegment is 1/2 the length of the third side. Okay. So MN is just half of AC. So let's just get a quick example on this. If I had said that this was 3, okay, I know it's half of AC, so AC is just going to be 6. And when you're solving problems like this, the easiest way to find which two sides are what we're talking about, you're just going to look at the ones that are parallel. Okay, so we're going to skip this proof right here, and we're going to go straight down to number 4. Segment XY is a midsegment of triangle DEF. Okay, that tells me something about points X and Y. This statement right here tells me that X is the midpoint of DE and Y is the midpoint of DF. Okay, that's important to know. All right, so what we want to do is we want to find XY. Okay, XY is that midsegment, right? So the length of XY is just going to be, by our triangle midsegment theorem, it's going to be half of this third side EF. So it's going to be 17 divided by 2, which is going to give me 8.5. Alright, so XY is just 8.5. Just dividing that by 2. Alright, DX. So this is where we use the fact that X is a midpoint of DE. Okay, it does not look like it. The figure is not drawn to scale, and I think that's on purpose. It doesn't want you to assume anything from the picture. It wants you to use the fact that X is the midpoint. So if the midpoint, I know it's exactly in the middle of D and E. Okay, so the segments on either side are the same length. So if XE is 6, then DX is also 6. Similarly for point Y, if DY is 4, YF has to be 4. Okay, that's number 4. Now we're going to add a little algebra to this. QR is a midsegment of triangle WYZ, excuse me. So I know that QR is half of WZ, right? So I can set up an equation, instead of saying that's 2x minus 2.5 is equal to half of whatever this is, how about we say, I know that 2 times this QR, which is 2x minus 2.5, is going to be equal to whatever the WZ is, which is 2x plus 7. So let's solve our equation. Now we get 4x minus 5 equals 2x plus 7. So 2x is equal to 12. So x is equal to 6. Okay, cool. Now let's plug in to find our WZ. So 2 times 6 plus 7. 2 times 6 is 12, plus 7 gives me 19, so WZ is 19. And then I know QR is just going to be half of this. 19 divided by 2 is 8.5, and we are finished with this one, okay? So it's really easy once you have actually gotten the numbers. Finding the x is the hardest part on that one. So problem 6 and our last problem for this video is this. We have triangle QRS, and we know that T, U, and B are midpoints. Okay, that tells me that these lines that we've drawn right here, TU, UB, and TS, are midsegments. So that helps us a lot because we can use the triangle midsegment theorem. All right, so we know that QS, which is this whole thing right here, is equal to 50. I know that SR is equal to 40, and then TB is equal to 30. So let's find TU, okay? TU is this right here. All right, so this is a triangle midsegment, like we said, and our third side, we look at the one that's parallel to it, and it's going to be RS. So I know that TU is half of RS from the triangle midsegment theorem. So RS is 40, so TU has to be 20. That's just half of it. Okay, UB is parallel to QS. It's a triangle midsegment, so half of QS is 50, so half of 50 is 25. So UB is 25. And then QR, we know that TB is 30. QR is the parallel, and it's the third side this time, so instead of halving 30, we're going to double it to get that QR is 60. And with that, we have finished our notes for 15.1, excuse me, and that is the end of the video for this. If you have any questions, please feel free to email me. And that's it. Thanks, guys.